Sarah, you're in. I'm in. The audio's on. There's one attendee so far. 14 participants are coming in. So
let me know when I should share my screen. I can't be the host.
Okay, you're the host.
Yeah, you can share it. Are we on? Wish we could see the panel on the side to see who's in here, but Amanda's given us the go-ahead. Amanda, the Tableau community coordinator, thank you very much for setting this up. And welcome everyone to the Dev Office Hours. This is a webinar series produced by the Tableau community in collaboration with the development team. The development team today represented by members of the Tableau Maps team. So we're going to briefly introduce ourselves, and then we're going to go over basically a series of demos that we put together and have some Q&A back and forth with people who are logged into the chat. You can ask questions via the chat because I think audio is off for all participants. So with that, we can start with some introductions and introduce ourselves. I'll go first. My name is Kent Martin. I'm a product manager on the Maps team. I've been here at Tableau for 3 years. I've been able to present on a couple of these webinars before, and you may have, if you were at TC last year, seen me on stage where I got to whoop it up with some of the features that we're going to show you today. We'll go around this way. Sarah, why don't you introduce yourself?
I'm Sarah Battersby. I'm a manager on the research team here, and I'm lucky enough to get to play with the Maps team when they let me do fun things.
Sarah's short selling herself. She probably writes the most popular Maps-related blog in the Tableau community. Awesome. Ryan?
Hi, I'm Ryan Whitley, manager on the Maps team, focusing on Maps data.
Cool.
Hey, my name's Ashwin. I'm a product manager on the Maps team. I'm really excited to be here. Thanks for coming, guys.
All right. So the way we want to do this is basically jump right into some demos. And I'm going to kick it off with Sarah. She can go first. And Sarah, I think, is going to run through something that isn't really feature-based, but how to produce a particular style of map, which is very interesting for folks. And you blogged about it recently. Is that right, Sarah?
Yeah, so I wrote a blog post on dot density mapping in Tableau because I had a question from one of our Zen masters on whether this was possible, and it seemed like it might be kind of fun to think about, and it turns out that you can do it. So I'm going to show you a little bit of novel mapping with Tableau that you might not have known that you'd be able to do. So I'm just going to start with where I got the data from this, just so in case you want to redo this or get some good data sources. I grab a lot of data from the US Census because if you go to their Tiger website, they have some really nice data sets with demographic and economic data already built into them. So these are shape files that you can download, or you can grab cartographic boundary shape files, and those you can just bring straight into Tableau and join them up with attributes that you can grab from the American Fact Finder on the census. So I'm a huge fan of getting data from the census, so I thought I'd use those for my example. So what I'm going to do is build a population map. So I've got some data that I brought in from the census. I'm going to drop my county level data onto the map, and I'm going to go ahead and make a population map. Because if you've seen any of my talks, you know how much I love population maps. So this is just population by county for the US. This is a pretty typical way that we would make a map in Tableau. We made a choropleth map. We've got a single value for every county. And this is good, but it's not telling us a whole lot about the distribution inside those counties. We just assume there's a single value for every county, but we don't know anything about how those data points are distributed. So we could start looking at finer geographies. So I might look at it at something like the census tract level. And the census tract level is just going to be a much smaller geography. And yes, you can download this data set straight from the census. It is 574 megabytes, and it takes a little bit of cleaning because there are about 6,000 attributes. But you can just drop it straight into Tableau and make that map. But this also isn't really giving me what I wanted in terms of a nice, smooth, continuous distribution of population. So I thought, let's make a dot density map. And the ways that you can do that in Tableau is by putting these census files that you download straight into a spatial database like Postgres. So I have a database here, and I went ahead and just did a quick selection so you can see what the data looks like once I put it in here. But I've got a geometry, so this is actually going to tell the database what the polygons look like. I have some really cryptically named columns like BP 001, 0001. And I actually read the file from the census to know that that's population. So I can take that and throw it into Tableau and create a little custom SQL. So I have a custom SQL query here. So I'll make it a little bit larger so it's potentially legible. And what I'm doing is I'm having Tableau connect directly to that SQL database. And I'm saying for every one of these counties, or for every one of these census tracts, whichever data set I'm using, grab the population, and then generate a number of random points, X and Y locations, and give that to Tableau as my return. So I can then take that data, gives me a latitude and a longitude, which I can drop on the map, and now I get a population dot density map. What's cool thing about this is because I'm using a custom SQL query, I can use parameters in that query. So this is telling me to create one dot for every 25,000 people. Maybe I want one dot for 50,000 people. I can change the slider in Tableau and the map's going to update automatically. So this is nice with counties, but it's actually a little bit nicer, I think, with census tracts. So when you add in the census tract data, you get a lot more geographic detail, get a lot finer level for that. So you can see this dense urban core slowly fading out into the less dense areas. And again, I've got a parameter so I can try out what level of simplification I want. Should one dot be 1,000 people? Maybe that's a little too much. Should one dot be 10,000 people? Maybe that's a little too little. So I can use the parameter to customize how that map is going to end up looking. I can also do it up with a little Firefly style, so it glows a little bit. Or I can add in some other custom symbolization. So here I've classified the data and used different colors for different densities of census tracts. And again, I can change my level of aggregation, how many dots per, or how many people per dot, and tailor the view to just what's going to work for me. So that's how you can make a dot density map in rapid form, but I did write a blog post on this last week, so you can find that on the Tableau community forums under my name.
So Amanda, it'd be good to know if there are any questions about this, but I have some questions seeing this and just hearing what you're talking about. So we're looking at South Carolina here, right?
Yeah.
And you said you had classifications.
Yeah.
So how did you go about building the classifications? What are those classifications? Can you give us a little bit more information? I know this is something that comes up a lot in the community as well.
Sure. So I knew that I wanted different colors. So for every census tract, I wanted to be able to highlight the ones that have really high populations a little bit more and take the ones with lower populations and fade them into the background a little bit. So I created a really quick calculation in Tableau. And I just said, if the population of a census tract is more than 500 people, give it a 1. If it's greater than 250, give it a 2. So that's between 250 and 500. If it's between 100 and 250, give it a 3. And if it's less than 100, give it a 4. So then I can set up the colors so that my 1, so my highest population census tracts are going to be the brightest color on the map. Since I'm using a dark base map, I want a really light color for this. So I used yellow all the way down to our lowest population census tracts, our 4s in this classification scheme, which I gave a darker color. So then when I put those on the map and I make sure that the 1s are being drawn on top, let me see if I can remember how to get my legend back. You remember how to get a legend back?
If it's not right off the pill, you can go to Analysis.
Analysis, Legends.
Legend.
All right. So my color legend, I've got my 1, 2, 3, and 4, and I made sure that the number 1 class is on top. Otherwise, we just throw the 4s on top. It makes it so that orange doesn't, or the yellow doesn't pop quite as much. So I can just drag 4 down underneath, and those yellow values rise up to the top. It just makes it a little bit glowier and nicer to emphasize the patterns. I also use some transparency to make it so that the densest areas are really the brightest, and the areas with lower density fade into the background a little bit more, just to see what the difference is. At 100%, you get kind of this like glowy, fire-ridden South Carolina. And then if you take it down to about 30% or so, those low population density areas really fade into the background a little bit more.
So maybe a quick summary, Sarah. You said you had data from the census, right? You had spatial files and attribute data from FactFinder.
Mm-hmm.
You loaded the data into Postgres,
Correct.
leveraged Postgres's operations to basically generate a new data set which had latitudes and longitudes. And then from there, you're bringing everything into Tableau. Is that right?
That's right.
And then for the Firefly Map, maybe you can just tell us a little bit about the styling there and how you made it glow so much, because we all like a little sparkle.
Sure. So yeah, Kent is my best advocate here, I think. So this is what's called a Firefly style map. And I just wrote a blog post on this earlier this week about how you can create these maps. What it is using a custom shape for point symbols in Tableau. And that custom shape has a transparency built into it. So it uses bright colors that show up really well, high contrast against black background. And then the actual shape that I'm using to draw the point has this gradient. So it goes from full saturation, fading out, so that when they start to overlap, you get this really interesting glow to the symbols. So that's just a custom shape. And I've got a number of different colors, so I can make this a nice glowy green if I want. Let's move this out of the way. We can go with a nice glowy yellow or an orange, or we'll see what this one looks like, because it'll be kind of weird. We're just gray.
But you shared all these on the blog post.
These are all.
Anyone can go grab them from the.
Yeah, these are all on the blog post. I actually included the symbol set. You can download that directly from my blog on the community forums and drop the symbol straight into your Tableau repository, and you'll have some nice glowy symbols to use.
Yeah. So Amanda, were there questions here in the chat? I can't quite read them.
Yep, there's two questions from Lila. The first is, what if we wanted to chart other data? Would we need to do a join in the database?
It depends what other data values you want. I mean, if you want to be able to use them for a dot density map, you would need to have them in the database with the geometries. If you want to just be able to put other attributes on top of the points that you've created, so you don't want to, you want to create your population map using the population values, but you want to add another characteristic on top of them, you could then join that in directly in Tableau. So you wouldn't have to do all of it in the database. The only things you need in the database are the geometry and the value that you want to use to generate the random points.
Okay, her second question, will this still work if we use the database hosted locally on our computer and then do an extract?
This database is definitely local on my computer. I think if you create an extract, it's not running out of the database anymore. Is that right?
Well, yeah, it's not on the extract, but I'd have to check and make sure, because you're still, you're leveraging the operations of the database. You need to pull out the raw data in the extract itself. And when we use custom SQL, I'm not sure if that's actually pulling out all the data. Yeah,
you would have to definitely talk to the database if you want it to be dynamic.
Yeah.
I think if you figure out your single value that you want and then you extract that, the data set will probably be snapshotted and you'd be able to use it without having to connect back to the database. I use the database because I often don't know what values I want. But if you've already got it figured out and you've used the parameter to tailor the map just how you want it, then I think when you extract, it'll probably just be snapshotted and good to go.
Yeah, so we can
test
we'll follow up on the actual page, the Dev Office Hours page, and we can provide links to Sarah's blog, which she mentioned already a few of the entries, and then we'll follow up on some of these specific questions which we haven't answered here yet, and get back to you that way. So I think that's a good way to proceed. Is there one more question there?
It's just a comment. We love these maps. We're planning to send them in our blog post. And then can you show the, I don't know how to pronounce that,
Core plot.
Thank you, and explain further how to make them.
Sure. So a Core Plus map in Tableau, I mean, that's really our out-of-the-box mapping option. Anytime you're putting color onto a Polygon data set, you're going to get a Core Plus map like this. So I'll make one just purely from scratch. We'll take our counties. So I'm using the GeoID10. So this is a unique identifier that our geocoding, our geocoding in Tableau recognizes as being counties. So I can drop that onto my map. Tableau is automatically going to say, hey, I know that these are county identifiers. Here are all the point locations for all the counties that I've found. And then when I want to turn that into a Core Plus map, all I have to do is drop a measure onto color. And Tableau is automatically going to generate that. That is the entire trick behind it.
Cool. So let's stop with the questions there. Amanda, I don't know if you can actually post links into the chat while we're chatting.
So yeah.
Yes, you can post the Dev Office Hour stuff that I think people are asking about. I think Ashwin, you're going to go next and talk about an enhancement that's coming out in the 2018.1 release. Is that right?
Yeah, that's right, Ken. Thanks. So I'm really excited to share this with you guys, because this is something that has come up time and time again on forum posts, in talks with customers, and through other mediums. And I'm excited to say that this is going to be dropping later on this year, and it's an enhancement to current dual axis mapping functionality in Tableau. The official name for this feature is the dual axis maps for custom generated latitude and longitude. It's kind of a mouthful. So let's just talk about what you can do with it and how it works. So I got a quick demo prepared here. And let's pull that one up. We're over here. Cool. So essentially what I'm going to do with this feature is I'm going to overlay point data on top of Polygon data. So let's say in this scenario that I'm a journalist and I'm really interested in looking at political polling centers in the Los Angeles area. What I've got here is I've got two data sets. I've got an Excel file that contains various information about my polling centers, which has the name, the latitude, longitude, etc. And I've got another file of congressional districts in Los Angeles. So I'll bring those two into Tableau together, and what I'll do is I'll make a full outer join here, and I'll just make a quick calculation here of 0 equals to 1, so it grabs all my data from each data set. Okay, cool. And that's it, we're all done. Now we can go into our sheet and start figuring out how to build this dual axis map that overlays our polling points on top of congressional districts. So first what we're going to do is we're going to grab our congressional districts and plot those on a map. So immediately we can see that we can see these shapes, and we want to know, okay, where are the polling centers located relative to each of these congressional districts? So the way we do that is we leverage existing functionality in Tableau that you can do today, and you create a dual axis map. So we'll control click the latitude pill up here and copy that, and then now we can go to either one of these marks panes. I'm going to go to the bottom one here, and I'll take off the congressional districts. And then I'll select both my latitude and longitude pills. These are my custom data, the polling centers, latitude and longitude. And I'll add those to detail on the marks card. Finally, what I'll do is I'll make each one of these dimensions, plot all of them on the viz. I'll change the color so it's not all blue. Maybe make the size a bit smaller so it's easier to see. And then finally, come up here, it can dual axis maps. And now we can see that we have the polling centers overlaid on top of our congressional districts. And this is really cool because this will work for any built-in geocoding role in Tableau. So if you've got states in the same data set as your polling places, you can now overlay both of those on top of each other. Anything you want to add? Yeah,
that's great, Ashwin. So, this is like really easy and quick to show. So maybe it's a good idea just to say, what would have happened before? What would we have seen before if someone tried to do this exact thing?
Mm-hmm. Definitely. So before, what would have happened if I had tried to do this? So we're going back a few steps. At this step right here, if I try to add in my latitude and longitude pills that represent the locations of my polling centers, nothing would have shown up on that second viz. So before, you actually couldn't have even made this type of overlay map.
Right. So basically, when you're using latitude and longitude that are generated, either coming from a spatial file, like the actual native spatial column, or from our geocoding database, that superseded all latitude and longitude. Mm-hmm. And what we've done is just let Tableau know that any latitude and longitude can work together.
Yeah.
This is sort of a stepping stone to making any latitude and longitudes work together in n number of potential layers. So we've made one little tweak here for dual axis maps. And I know you mentioned that this has come up a lot on the forums. I think you sent me a list of forum inquiries that was something like, a dozen forum posts that had some kind of question related to this type of feature. Is that right?
Yeah, there are tons out there, and that dozen I found was over just a couple of minutes. So I'm excited to say this is going to drop later on this year. So stay tuned for that.
Yeah, so just to talk about how challenging it has been and how much of a problem it's been for a lot of people. My blog post on dual axis mapping is probably the most read post that I have created because it's been hard to get them right and get the data sets to work together well. So I'd like you to know that I probably have to rewrite that whole post once this is actually out. Thanks.
And I guess, the other thing too that you showed in this example was you did show like the full outer join case where there's no matching attributes between the data sets. But it'd be possible to do this exact same thing if I had just the polling station data, so long as it included something that was geocodable.
Definitely.
Right? Or if I had a shapefile that included latitude and longitude but also the native spatial column, again, you could just work off one table. You don't need to join two tables or have them be separate. As long as you have those two sets of latitudes and longitudes, you can overlay them together.
Can you give us a sense of when this is going to be available?
Yeah, I mean, I think for 2018.1, that release is targeted just, a few weeks away. So I think we're looking at early April.
Awesome.
So it's definitely not long-term. It's kind of coming around the corner.
We got till early April to update the blog post.
Yeah.
We have a question from Daniel. What if I want to name each polygon on the shapefile so when I move the cursor around the shapefile, it shows features about each shape? Is that possible? And then what if I want to know, so many questions just came in. What if I want to know the number of points in a polygon?
You want to answer the first one, Ashwin, and we can kind of lead into some of the other stuff we're going to show?
Yeah, sure. So that first one, that's totally possible. If I had a richer data set here, I could do that. What I think you're asking is, so here I've got a name field, which I believe shows the name of the congressperson for each district. So if I add that to detail, we can see that the name of the congressperson appears. I think that's what you're asking for. Did I get that right?
Yeah, I mean, they're really just asking for how do we tie attributes to the actual geography. And so there's a number of ways to do it. You basically added this one field to detail, which automatically applies it to the tooltip. You can also add it as a label. Of course, you can write custom labels and annotate the map. But basically dropping anything on the marks card is going to automatically incorporate it in the tooltip. So you get that one for free. I think there was another question here that was about
Count up the points.
counting points and polygons. Let's hold on to that one for a second. We will get to answering that question. In this specific case, you're going to have to, because of the way that this data was joined together, that there's a full outer join. There's no actual link between the rows from the one table to the other table. So you're not going to be able to easily count them like automatically. You'd have to actually go and do an interactive selection. And we have interactive selection tools like the lasso tool, which you can actually trace around and grab something. But it's not really, it's kind of an intensive and error-prone manual operation. But hold that thought. We'll show another feature. Ashton's going to show another feature later. Well, why don't you just show it now and jump ahead? We can help answer this question. So yeah, we do have a feature that's going to support that.
I'm respecting all the questions that are coming in. If we don't get a chance to answer them now, we'll circle back on the forums and the thread.
Yeah, that sounds great.
Yeah, so thanks for that other question about counting up the points within spatial regions. So the team has actually been working on that exact scenario with a feature called Spatial Join. So Spatial Join is exactly what it sounds like, I guess. It allows you to join two spatial files together and count the points that are within polygons. So with this specific example here, so I recently moved to Seattle, and one huge thing I noticed about living up here is that bike sharing is super common. You've got bikes all over the place, blue, green, red, and it's really popular. So I got to thinking, okay, I wonder how many bikes are located in each of the neighborhoods within Seattle. So what I did is I got two spatial files here, two shape files. One of them contains the neighborhoods of Seattle, and one of them contains bike share information. Let's go ahead and let's grab both of those. And then we'll bring them in to our join screen here. And this is the part that's new right here. And this is the part that creates the connection between both of our data sources. So we click that join icon in the middle. We can see that there is now a new option called intersects. And what this is going to do, it's going to intersect our point data with our polygon data to create a connection there and figure out which points are located within which polygons. So if we click that, we're all set to go. So now, for that specific scenario, we can plot our neighborhoods on our map. And in case you're not familiar with the regions in Seattle, I'll put the name on detail as well. So now we can see where each neighborhood is located. And then we will take the number of records here and put that on the color. So now right away we can see that we have our data spatially aggregated across all the different neighborhoods within Seattle. So if we hover over each different neighborhood, we can see that there is one bike in Interbay, 188 bikes in South Lake Union, and 114 bikes in Wallingford. This feature it's really special because it allows you to spatially aggregate your data in Tableau. What if we wanted to go a bit further? right? What if we wanted to use some of these other fields that we have here and talk about the average downtime between bike usages in different neighborhoods? That's really simple to do now too. So actually, let's go ahead and let's make some quick edits to this field right here. So first, we can rename this really easily, fix that spelling error. Average downtime. And we'll go ahead and change this to be a number. Cool. So now, just like before, we'll go ahead and we'll plot the geometries on our map. We'll add the name so we can know which districts we're talking about. And then we'll take our average downtime, put it on color. And to make this easier to understand, we can just edit the color legend right here and pick a palette that more suits my taste. I personally like red, so I'm going to choose that one, assign it, and we're good. So now again, we can see the average downtime divided up among our different districts in Seattle. And we can see that the bikes in Queen Anne have 15 minutes between their usages, so they're used less frequently, whereas the bikes in South Lake Union, where we had a lot of bikes, are also being used very frequently. What if we only go one step further? And we can see that we have this working pill. Let's take a look at what's inside that really quickly. So the working pill looks like it's an indicator variable where it's a 1 if the bike is in working order, and it's a 0 if the bike is broken. We got one right there. Let's see what we can do with that. So again, we'll make this a number. And we'll create a quick calculated field because I'm more interested in seeing the percentage of bikes that are in working order across each district. So we'll make a calculated field, and we'll say percentage of working bike, and we'll say working divided by number of records, and then times 100 to make it a percentage. And remember that here we're already aggregating across each district. Then again, just like before, we'll put our districts on the map. We'll add in the names so we know what we're talking about, and then we'll take our our calculation that we just made, put it on color, and we'll make that an average. So just like that, now we can see pretty quickly that over on the west side, our bikes are looking in pretty good shape, right? 100% in working order. South Lake Union is looking pretty good, so it's a lot of bikes are in South Lake Union. They're being used pretty frequently, and a lot of them are in working order. And we can see on the east side here, we have a lower percentage of bikes in working order, so maybe we want to figure out what we want to do there. And the coolest part about this is you can even combine this with the earlier mentioned dual axis mapping feature and really get the most out of your data. So again, we'll combine that into this workflow. The same thing, we'll copy the latitude pill, put it onto the marks card, remove what we have on there already. Then we'll take the latitude and longitude pills from our bike data set. We'll make those dimensions. And because I want to see where the bikes are broken and where the bikes are in working order, I'll put that indicator variable onto color, dual axes together, and just like that, we're all set. We can see the percentage of working bikes in each district in Seattle and where the broken bikes are located.
Yeah, that's cool. So yeah, Ashwin's showing Spatial Join, and Spatial Join is set to be released later this year. We're targeting it for the 2018.2 release, so in the second quarter of this year. But yeah, we basically, we've done a lot of testing on this feature. We're really excited about its performance. Ashwin's data set here, it was fairly small in scope and local data set, but we've definitely tested it against, tens of thousands of complex polygons, or 100,000 points against, a complex boundary data set, and the performance is really good. I want to mention a few of the limitations of the feature, just so people are very clear with what we're delivering. And we're focused on working with points and polygons. So if you have discrete events or objects, assets like bikes, customers, or oil and gas wells, or you're counting animals in a wildlife survey, all those types of things within any common custom geography, you're going to be able to use this feature and do counts, but also do that spatial aggregation that Ashwin's talking about. So it really is opening up a new type of question you can answer in Tableau, because before, what did you have to do? You would have had to pre-process this data. So, for some of us that are familiar with working with third-party tools or other mapping applications, or just more hands-on in the database, that might have been, an accessible approach, but now we're kind of putting that right into Tableau. So long as you have the spatial data, you can answer these types of questions. So, Amanda, I don't know if I saw some chatter going there. Were there any questions that came up?
Yes. Is the map data able to use the Tableau clustering feature?
Yeah. The question is basically, can you use clustering against geographic data? The answer is you can. If you, Ashwin, maybe you can just drop it on the analytics pane there. In this case, we're looking at dual access and there's a problem, why it's all disabled, but, or there's not a dimension on the particular biz that it could pick out. But basically clustering is going to need to use a dimension. Is that true? I'm lying right now, aren't I?
I have not used clustering.
It certainly doesn't need to just use a dimension. I don't know why it's not showing up in the dual axis view. You have to clear out this stuff. Just drop neighborhood and take out the add the neighborhood name, just a detail. Let's go back to analytics, the pane, see if it shows up.
Maybe just drop the points on to cluster the points.
Yeah, but you can cluster. One of the demos we showed with clustering is that you can make like a map of the world against some like health indicators. So it's not dimensions or measures specific. Of course, you can use any one of those types of fields. I know you can do it. I don't know why in this particular case it's not showing up.
Maybe for this case, I'll take this one offline and I can get your contact info from Amanda and follow up with you personally about that clustering question.
We can just post it onto the forum thread that we have going. I know clustering does work with geographic data, so maybe it's just the spatial part of this, like Sarah's alluding to.
There's a question from Eric. Is there any way to post either some of the raw data files, Tableau workbooks, or links to the source data online so we can try some of the techniques we have seen today for currently available functionality?
Yeah, totally. So, I mean, with all the workbooks that we have, I mean, we'll post stuff that we can share easily. I know Sarah's already got some of her stuff available via her blog, and stuff that Ash and I show we can easily provide. So all that stuff we're just going to attach and add to the community thread that we have going. And if there's follow-up that's needed, we can just work through Amanda or through the threads and just do back and forth that way.
Lila, our new Zen master, commented, I think it actually needs a numeric field for the clustering.
Yeah, so in this case, we only have dimensions. We need to pull out some numeric field, like you got percentage of working bike or something like that. Just drag that onto color and go to analytics pane. And if you bring cluster onto it, then you can make a choice. It only has that one value. Usually you would have more than one value. So yeah, it'll work. Okay. Is there another question there about?
Yes, from Daniel. Could we test the release before it's released, some alpha beta program, for Spatial Join?
Daniel, of course you could test the release before the release. We definitely have an early feedback program, and we've actually had a lot of the community involved in testing Spatial Join already, and another feature that I'm going to show you here in just a minute. If you want to be a part of that early feedback, the best way to do it is to make sure you're part of the Tableau community, to go to, there's a website link. I don't know if it's early feedback now. It used to be just beta.tableau.com.
Yeah, I can post it in the forums.
But it's definitely, once we now have sort of a centralized way of giving early feedback through beta programs or early releases. So we'll make sure that that's posted as well. And we want people to be able to test this. Obviously, we want you to use your data and validate the development that we've done. So thank you for asking that. For anyone who wants to test any of the mapping features that are coming up, just raise your hand on the forums or leave a message on that thread, and we'll make sure that we contact you. So with that, I'm going to show one more demo that we have planned for a feature that's coming out in the 2018.1 release. And it sort of builds on top of what Sarah was showing working with spatial databases. So we built a new capability for working with SQL Server databases in Tableau. And what I'm going to show here is I actually have a workbook with completed work. And yes, Sarah alluded to me liking sparkles, and I also like polka dots and sprinkles and things that look like a donut that Homer Simpson might eat. But in this case, I'm going to walk through how I actually made this visualization and what it represents. So here, I'm looking at schools and parks within the city of Seattle. Now, the data sets I had to work with were all point data sets, but as you can see, these aren't just points anymore. They're these large sort of buffers or large circles for the areas around schools and the areas around parks. And what I wanted to do was figure out, within a certain distance of a school, basically how many parks would intersect with that area around the school. So I'm going to jump back to my data source and show you a custom SQL query I used with my spatially enabled database. Let me zoom in here again, like Sarah did earlier. And I'll walk through the custom SQL statement that I made. So it's very simple. What I get now with SQL Server is that I can work with spatial fields. And in this case, I'm just pulling out school name, park name, but I can also bring in the result of a buffer as an actual geometry. So I can actually bring that spatial column natively from the database into Tableau. So where Sarah was basically doing some manipulation and conversion of spatial data from Postgres, which we don't natively support yet in Tableau, with SQL Server, we can actually read the spatial data directly. And so once I've chosen the fields that I want to work with, I can leverage the operations in the database to basically do some spatial analysis. So here I've actually created a join between the parks and the resulting buffer data set. And I'm using a radius, or as well, I've inserted a radius into the statement so I can dynamically manipulate that inside of Tableau. So I'm going to say OK to that and jump back here. So once I had that data set, that basically would have allowed me to draw this buffer around the schools. But the other interesting thing I want to show you about how I built this is this one calculated field. So in this calculated field, we're using a raw SQL statement to pass in geometries into a specific statement that will actually perform this one specific spatial operation supported by the database between the two geometry data sets. And it's called intersection. And you can think of intersection as like basically a cookie cutter, right? It's not just going to tell you the things that overlap each other and include all of the parts that overlap. It's only going to include, it's only going to include the parts that overlap. It's not going to include every aspect of the underlying geometry if it intersected at all. So that's best shown by just giving you the real example. So I'm going to zoom into this one park area, and you can see that this buffer from one of the parks that I have here, and the intersection result of that buffer is that it cut off the circle so that we don't see anything outside of the buffer. And that's how you get that effect. I'm leveraging the spatial operations of SQL Server to buffer point data sets and perform an intersection so that I only see the data that's within the area of interest that I have. So I can go back out here a little bit. And as I mentioned, I added a dynamic parameter to the query. So here I have that parameter already set up, and I can simply use that parameter to expand my buffer in the range in which I'm looking at. Within 1,000 meters of schools, you can see how many parks are visible. If I bring that down to say close to 500 meters, well, what stands out is that some of these schools, like here, no longer have parks within a half a kilometer or so. So again, you can start to explore this data set and access to parks around schools. But again, this could be any other type of data set that you have. If you have, bike racks and you want to look at sort of proximity around bike racks within neighborhoods, you could leverage this kind of functionality. So I'm going to stop there with this specific example and see if there's any further questions. But again, for this, I can post the SQL that's used and any other relevant resources to the community thread so people can follow up and try this themselves. No questions on that one? Cool. Well, that gives me some time.
Lila asks if this can be done now.
Can this be done now? Well, the thing that can be done now is you can author custom SQL. The thing that can't be done now is that you can return spatial objects from the SQL. So with SQL Server, the other part of that is today in Tableau, the not yet released version, but in the beta version, or sorry, not including the beta version or the release versions, but in the 10.5 release, SQL Server, if you made a connection to this database, you just wouldn't even see the spatial field. It wouldn't even show up in the table. We just ignored it. But now in the 2018.1 beta and in the release that's upcoming, you'll be able to see that spatial field and return spatial objects.
Cool. First question from Daniel, will you support PostgreSQL, the GIS version too?
Yeah, Kent.
Yeah, no, that's a great question.
I ask him this about every week.
Yeah, I mean, well, let me take a step back and say, yes, we intend to do that. Of course, until a feature ships, we reserve the right to hold back and make sure that we do it right. One of the things that we've done here at Tableau, if you followed all the mapping features over the last couple of years, is build a foundation for working natively with spatial data. So in a nutshell, we're a data company, right? And we don't want to think of mapping data, spatial data, as being this very special thing that only certain tools work with. The way we look at it is it's data. And so we built support for spatial data the same way that we have support for numbers and strings and dates. Spatial is just something that Tableau knows about now. But of course, each of these data sources, they have a little different flavor to them, and we can't just have a generic implementation that allows us to work with all spatial data right away, right out of the box. So what we did first was support spatial files like shapefiles and KML in the 10.2 release, and that got that spatial knowledge built into Tableau. And then we worked on what we determined was the most popular spatial data source by our customers. We did survey a large number of customers, and they were very clear in the response that SQL Server was most prominently used. But the other data sources that they also said in that survey were Postgres, Oracle, Teradata, and others. And so we have those on our list of things that we want to support. We just want to make sure that we're addressing the most important things, like the highest priority things that have the most impact on people's work as soon as possible. When you say the GIS version, you're basically talking about either PostGIS or like you're thinking about it as like Esri, SDE kind of thing.
Yeah, PostGIS.
Yeah, I mean, the way that we're going to implement things in Tableau is that you're going to be able to leverage all parts of whatever your implementation is for Postgres plus PostGIS. So, that's our intent. But, again, that's not going to happen in the very near future. We'll see when we can get to it.
He says thanks.
Yeah, you're welcome. But you have to promise to help test it, right? We definitely need people. I can't say promise. I mean, that's a bit strong, isn't it? But the same way that we're saying we're going to work on it, it'd be nice to have people participating and helping ensure that we're building the right thing, which is what we're most concerned about, that we get it right and that we have that quality.
He says that he will, so we're going to hold you to that.
Oh, great.
A question from you. Moving this around. When I used to use shapefiles, Tableau was very robust in handling all the spatial objects, but when I transferred spatial data into SQL Server, the SQL Server preferred spatial data type WKB, problems on spatial data quality come out. Is it possible to know how Tableau is handling spatial data, in particular the spatial data type, whether it is WKT, WKB, or other type?
Yeah, so, I mean, this is a very specific question on the implementation of our spatial type. And I can tell you our spatial type is not WKT, well-known text, or WKB, well-known binary. Those specific types that are supported by, they are supported by databases. I could write well-known text in any common data source as well. If you want to understand specifically what's happening because of a problem you're seeing by converting data or loading data into your database, or if you want to see Tableau support direct read of well-known text or well-known binary types, it'd be good to talk about that. And again, I would suggest the best way to follow up on this is a more kind of complicated question, and I'd want to dig into what are the actual needs and use. Let's follow up on the thread, and this is Steven Zhang, right? Mm-hmm. So I know Steven Zhang has posted on the threads about this before, so I can sense the passion of Steven here to really make sure that he knows what we're doing and how it's going to work. So I can make sure that we have a conversation on the threads or do something offline, like set up a call. So.
Okay, we had a couple questions pop up in the Q&A, not in the chat thread. So this is from Caesar. Has the team considered adding a jitter marks function / button that would randomize within a small radius? This is from about 9:30, so about 20 minutes ago.
Sure.
Hey, Caesar, you should go read my blog post on jittering data. I'll send it to you.
Caesar's probably read all that stuff there. You know, whenever someone asks, has the team considered blank? I will generally say the team has probably considered everything that has been written on the forums, blogged about, discussed, you know, widely demonstrated in some way by a Zen master. I mean, we take in all that information and all that sort of feedback, or the way that people have figured out how to work with Tableau, and just ask ourselves, can we make this easier, and is it the most important thing to do? So in this case, I can say, yes, we've thought about implementing something that would allow jittering in Tableau. I would say that the best resource for knowing how to do this would be Sarah's post on it. There are other people who've written about this previously as well, and those are all still relevant. But as far as our plans for supporting jittering, which is basically dispersing coincident marks, there isn't an immediate thing that we plan on doing to allow that. You're going to have to use calcs and do a little massaging of the data for now.
Okay, a couple more questions. Are there classes available for advanced mapping? Do you guys know of any? Does Tableau offer any?
Classes available for advanced mapping, and I assume this is in Tableau.
I'd imagine so, yeah.
I'm not aware of any specific class. I mean, so much of what people are encouraged to do is to be really self-directed through the community, reading blogs. You know, we have posted videos on some of this stuff, but there isn't really a consolidated class, right? Like a 2-day, here are all the things that I'm aware of. I know we have an advanced mapping webinar that you can go watch, right? Like we've done those in the past, but because we're talking about features on this demonstration that we didn't have on the table 6 months ago, right? And it kind of changes the whole playing field for what's available to people. So even our current content might be a little bit, you know, starting to get a bit dated. So we're going to look to update that for sure as we start to get to the new releases this year. But beyond that, I'm not aware of any, and this is something that we can follow up on.
Or our Tableau conference, anything you guys do?
Yeah, at TC, there are a number of advanced mapping type of sessions that are held. I don't think we have any hands-on trainings that are specifically advanced mapping.
So yeah, Sarah's right. At TC, there will be a ton of ways in which you can learn about mapping, all other advanced related topics. Because mapping in Tableau too, like, you know, Ashwin was kind of showing some of this. You know, you can use a calculated field, a couple of parameters, and use some of those, you know, widgets and tools that are available in Tableau, and it can augment what you do with maps and spatial analysis. So at TC, there are several hands-on trainings that I know in the past they've done introductory mapping classes, but also done advanced mapping classes. And the last thing I'll say about that is that advanced, the term, is very subjective. So sometimes you come into looking for advanced analysis and you really don't have any background in mapping, and you know, you might hit that bar a little sooner than other people who have lots of experience with it. So it is a bit of a challenge to actually make the right content, but there will be something at TC that is basically you know, a 2 or 3 hour long intensive task-based class. But outside of that, you know, we can follow up on the forums with more resources.
Okay, we have a couple more questions from Lucas. Say I have data with geographic dimensions on a level of country group, for example, European Union, Middle East, etc. Are you planning to implement a way to enable selection of countries from such regions, even though our data does not contain the corresponding countries?
Even though our data does not contain the corresponding countries.
to like EU, but not breaking it down.
Yeah, so,
I mean, it could be a point in Polygon if it could be treated as an intersection of two different data sets, assuming there are polygons for one of them.
I guess I'm not clear on the question, and I can speculate a little bit about how we might go about it, but if the customer is saying that, what was the name of this person, I'm sorry?
Lucas.
Yeah, if Lucas is saying they have EU data, and they're asking about how do we look at sort of country level data that makes up the EU.
Mm-hmm.
I mean, you need to have the country level data. Tableau doesn't know how to go get that country level data. So basically, we're going to visualize what you bring to the table. We're not going to fill in the holes if you have those in your data set. If you have all the countries that belong to the EU and you want to map the EU, well, you can use grouping functionality or custom territories, the feature in Tableau, and build out the EU polygon and aggregate data to that level. It's sort of like the inverse way of what I think Lucas is asking about. But you know, I'll make sure that I can go back through these questions with Amanda and make sure that we answer all of them, because I'm not sure I completely understand or that I'm answering it right.
And we can circle back. We have everyone's contact information on here too. So a note from Kristen, any reference materials, notes, slides, etc., would be very much appreciated for slow-bees like me. We will be posting everything from this thread from the presentation in the community forums, including a recording of this webinar. So please refer to that after this, and please share it with your community members as well, or your friends. Lila asks, I think it would be great to have some resources on deep diving into map basics on GIS, on just GIS data, how it works as a data structure. So.
Awesome. We will try to do more of that.
Okay, I think that's all we have for questions. Are there any more questions now? We'll give it a couple more minutes, or another minute.
Yeah, so a couple of things I just want to mention too, right? One is, you know, in this presentation, we talked a lot about custom spatial data, right? Like starting with shapefiles or data in my spatial database and so forth, or that I've gone and downloaded from a resource in one of those formats. But of course, one of the things that we want to make very easy in Tableau is geocoding. It is easy today. We want to make it easier. So we're always looking to build out new data sets and expand our coverage and improve the way that we have built-in data into the product too. So keep that in mind as you offer feedback. We know that data in the world updates frequently, and we want to make sure that we have the most up-to-date data in our product, but also supporting more granular views of geographic data in other countries. So know that that's also a priority that we have. I don't know where people are coming from who are on this call, but people often have talked about Tableau's geocoding being kind of US-centric because we have several roles that are specific to the US, or they used to be named in a very US-centric way. But it's definitely our priority to expand the coverage of geographic data that we include in the product to make it really easy for anyone to connect to their data for their country. So never forget, we're always working on that.
Okay, we haven't seen any more questions come in, so we'll close that out. All the resources will be posted in the community forums. If you have any trouble looking for that, it's community.tableau.com. I posted the link in the chat thread. And then we look forward to hearing from you soon, and we'll follow up with all the questions we didn't get a chance to answer today.
All right. Thanks, everyone. We can't see you, but we're waving.
See you later.
Yeah. All right.